Good evening, everyone. So, good evening. Today, we are moving a step further from expression. We are going into what we call equations. Okay? Equations. So, quickly, what are equations? As my habits and my culture, first of all introduced a particular term so that you'll be familiar with it. So that by the time we go deeper into the topic, it won't be a struggle for you to understand. Is that okay? So what is equations? What's an equation? Okay, I believe by now you know what's an expression. Is that correct? So if I write 3x minus 2, that's an expression, right? We all know what's an expression. We have worked on expressions. We have worked on simplifying expressions and factorizing expressions, opening bracket. We've done a lot about expressions. So now, equations is just a step ahead of expression. So if you know equation, if you know expressions, you should not struggle with knowing equations because it's just a step further. So what is an equation? An equation it is the equating of two expressions. An equation is the equating of two expressions. For example, if I have 3x minus 2 and I equate it to another expression, which is what x minus 1, then now I have what? I have an equation. What have I done? All I did was to equate what? Two expressions. Very simple. I equated two expressions. That's where the name equation came from. I equated two expressions. Is that okay? Now it's very simple. So the most important part of an equation is the equality sign. The what? The equality sign. That's the most important part of an equation. The equality what? Sign. Is the equality sign that is the most important part of that equation. So if you check an expression, the one we did the last time, you will not see an equality sign. You won't see equality sign. Once there's an equality sign, that means it's now an equation. Once you see an equality sign, I'm repeating it so that you can pay attention. Once you see an equality sign, it is an equation. If there's no, because they look alike. Do you get that? They look alike, but they are different. Is that okay now? So in an expression, you won't find an equality sign. You will find an addition, you find subtraction, you find other signs, but you won't find the equality sign. But in an equation, there will be an equality sign, and that's what made it an equation. And that is what defines what equation is. Is that okay now? Good. Equation. Okay. So quickly, let's move it. Now that we know what an equation is, now that we know what an equation is, so let's move a step ahead about what is now how do we now undo an equations when we see them in questions? How do we undo them? What do you want to do with them? So when you have an equation, what you'll be told to do is to what? Is to solve. What did I say? To solve. When you have an equation, you are expected to solve it. What did I say? Solve. Now, if you pay close attention to what I've been saying earlier, that means from the previous classes, when we were doing expression, you will not hear me use the word solve. I did not use the word solve. You won't hear me say the word solve. No. The best I would tell you to do is to what? Is to simplify. That's the best I would tell you to do. To what? To simplify. But I will not tell you to solve. Because there's a difference between solve and simplify. You cannot solve an expression. You cannot solve an expression. You can only simplify an expression. Solve. What does it mean to solve? Okay, let's talk about solve. What does it mean to solve? But I believe everybody knows the meaning of simplify. We defined simplify the last time. I said to simplify means to make it a bit what? Smaller, right? And by now, everybody knows how to simplify. You do that by just collecting the like terms, add it or subtract it as the case may be, and just make it smaller. Is that okay? So now when I say solve, what does it mean to solve? Now, this is it. To solve means to solve means to find a value for the what? A value for the unknown. Unknown. That's what it means to solve. To solve means to find a value for the unknown. Remember, unknown. Do you remember the word unknown? You remember when we started the expression, we said when you are writing a letter and you don't know what the letter is, sorry, you are writing a number and you don't know what the number is, what do we do? You represent that number with a what? With a letter, right? Why? Because you don't know it. Is that okay? You don't know the number. So we represent the number with a what? With a letter. Now, when I tell you to solve means that particular number that we did not know, you want to go and know it. We are writing a letter. For example, if I say 3x, I'm writing x because x is a number. It's a number, but we don't know the number. That's why we wrote x. I've explained this before, but this is just for we don't know the number, so that's why we wrote x. Is that okay now? Good. So now, when I not tell you to solve, it means that s that we don't know, go and know it. Now we want to go and know that it's no during expressions we don't solve, we just simplify. But now when I say solve, that means I want you to go and give a value, go and find the value of that number that we don't know. Go and find the value of it. We want to go and know it. We want to know that number. What is it? What is X? What is Y? What is Z? What is A? What is B? What is C? What is D? What is that particular number? We want to know it. And that's what it means to what? To solve. So and you can only solve when you have an equation. You cannot solve an expression. So if I give an expression, you cannot know the value of the unknown. You can only know the value of the unknown when it comes to an equation. Very important aspect you need to know, because many students don't know the difference. They don't know when to solve. They don't know when not to solve. All right. You can't solve an expression. So the best you can do an expression, the best you can do for an expression is what? Is to simplify it. That's the best. And you leave it like that. That's the best. You just simplify it. But when it comes to an equation, you need to solve it. You need to get a value. So at the end of your equation, at the end of an equation, you should be able to get something like x is equal to 2. Is that okay? An equation, when you solve an equation, you must end it something like this, okay? Meaning that now we know x. What is x now? X is 2. We now know what x is. Is that okay? We don't know x before, but now we know what? We know what s is. S is now what? S is 2. Is that okay? We solved this. So let's do an example, just a few examples to make you see what it means to really solve an equation. Okay, so let me give you a very basic equation like 2x plus 1 is equal to what? 5. This is an equation. Is that okay now? I believe you all know what an equation is, right? So anytime you say an equation, you should know that you want to solve it. You want to solve it. So how do I do this thing? It's very simple. The first step is to collect like terms. Okay. So that's what 2x is equal to 5 minus 1. So that's 2x is equal to 2x is equal to what? 4. Is that okay? So what do? You divide both sides by 2. Don't worry, I will explain better. For those that did not get what I'm doing, this is just for like showing you what it's meant to solve. So what is s is equal to 2? I have solved it. Now, when we're doing expression, we didn't do all of this. Okay, all we did in an expression was to simplify. Now there's an equation, we are solving it. Is that okay? Now this is what it means to solve basically. So now let's take a look at some other things we need to know about an equation. It's like I just showed you what it means to solve. We've solved it. In other words, we now know s. What is x now? S is 2. We know what s is now. We've known the unknown. We've known the unknown. So there's something we need to also learn under equations, and that is what? Collecting like terms. So I believe we all know how to collect like terms. We've learned that before in expressions. We've learned how to collect like terms in expression, but we also need to learn how to collect like terms in equation. This is quite similar, just a little different. Okay. Now, what is the similarity? Of course, not what is what. Okay, not the similarity. What is the rule of collecting like terms? What is the rule? So if I tell you to collect like terms, what is the rule? So the rule is that the sign in front of the number must always go with it, right? I believe everybody knows it by now because you've done the several questions. So the sign in front of each term must go with it. So now when we have something like 2x minus 1, so let me write it very well. 2x minus 1 is equal to x plus 5. Now there's not a basic thing you need to pay attention to in this particular one. Now I want to collect like terms. But don't forget this is an equation, right? It's meant for an expression. So to collect like terms here, are we together? To collect like terms here, 2x minus x is equal to 5 plus 1. Now, take a look at what happened. What is the sign in front of 2x here? Plus, right? What is the sign here? Plus 2, okay? What is the sign in front of x here? Plus, right? So what is the sign in front of x here? Minus. What happened? On a normal day, the sign should not change. Is that correct? But now the sign has changed. Why is that? Because it has moved from one side of the equation to another side. Now, if you don't know this before, pay attention. So why collecting like terms in equations? If you're collecting like terms in equation, and you need to move the particular term from one side to another side, the sign in front will change. So earlier, this particular s was at the right hand side. But now, after you collect like terms, it's at the what? Left hand side. So the fact that it changed sides means that the sign in front will change. Now, you don't need all of this on in expression because in expression, you don't have right side or left side. Okay, they're all on the same side. There's no right side or left side. But in an equation, there's a right side, there's a left side. So now, when you're trying to collect like terms and the particular term has moved from one side to another side, is that okay? Then the sign will change. Now, take a look at let's take a look at another one. Okay, so look at 5. What's the sign in front of 5 here? Plus, right? What is the sign in front of 5 here? Plus. Okay, so what is the sign in front of 1 here? Minus, right? Good. So what's the sign in front of 1 here? Plus. That one also changed. So why did it change? Because earlier 1 was on the what? Left hand side. But now after you collect like terms, it's now the what? Right hand side. Is that okay? So the sign will change. Solving linear equations. Solving what? Linear equations. Okay. So let's want to start learning how to solve now. So in the last class, I've introduced you to the fact that in equations we solve. Okay. We don't just simplify, we solve. And to solve means to find the what? The unknown, to know it. In expressions, we don't solve. You only what? You only simplify. Is that okay? But this particular equations we solve. And how do we know an equation? You know an equation by the what? By the presence of equality sign. By the presence of what? Equality sign. Okay, good. So now let's quickly dive into solving equations. So example 1. So if I have 3x is equal to 15. So this is an equation, right? So now what am I trying to get? I want to know what x is. I want to know what is x. X is equal to what? Is that okay now? So what I have there now is 3x. And 3x is not x. Is that okay? I want to know what is x, not 3x. So now that means I have to get rid of that 3. Are we together now? I need to get rid of that particular 3 because it is x I want to know, not 3x. Is that okay? So how do I get rid of that 3? How do I get rid of that 3? So I get rid of that 3 by dividing it out. So I will say 3x over 3. So doing this now, 3 will divide 3. Are you seeing that now? So what will I be left with? I will be left with what? X. Do you see that now? That's what I want to get. I want to take away 3 from there. But meanwhile, I have to do it for both sides so that it can be balanced. I can't just divide one side by 3 and then leave the other side undivided. I have to do it for what? For both sides. So I have to also divide 15 by what? By 3. Do you get that now? So what is 15 divided by 3? That's what? That's 5. No. So x is equal to 5. I've gotten my answer. That's it. X is equal to 5. I've solved it. How did I know I solved it? Because some people don't know when they solve a question. How did I know that I have solved it? I knew I solved it because I now know what is x. X is 5. That's what it means to solve, to know the unknown. Okay, another question to solidify that one. Another question quickly. So what if I have 4x is equal to what? 48. All right. So what did I want to get? I want to get x, right? I want to get x. And what is disturbing my x? That's 4. Not 48, 4. 4x is equal to 48. I want to know what is x, not what is 4x. So I need to get rid of my 4. I need to get rid of that 4 so that I can be left with what? I can be left with x because it is x I want to know. So to get rid of my 4, so I will divide 4 out, right? That's 4x over what? Over 4. Is that okay now? But meanwhile, I have to do it for what? For both sides. I have to do it for the left hand side and the right hand side. I can't do it for just one part. Is that okay now? So that means x 4 we divide 4, right? So let's with x now, yeah. I'm left with x now, good. It's equal to what? 4 divided by 48, that's 1, 2. That's what? 12. Do you understand? Good. So it's simple. It's simple. It's simple. Are you getting that now? So let's try another one. This number 2. Okay, let's try another one. Let's say we have 3x plus 2. Sorry, 3x minus 2 is equal to 7. Okay. This is a bit different from the one we did earlier. Okay, this is a bit different. So in this particular one now, I have 3 and minus 2 disturbing my x, right? So what do? The first thing I will do is what? To remove minus 2 by connecting like terms. Is that okay? So I will have 3x is equal to 7 plus 2. Are you getting that now? So now means I will now have 3x is equal to what? Is equal to 9. Is that okay now? So I divide both sides by 3, right? Divide both sides by 3. So I will have x is equal to what? S is equal to is equal to 3. Are we together? Good. I will have s is equal to 3. Is that okay? Good. So let's do more examples. What if I have 2x plus 2 is equal to what? 4x minus 1. So what do I do here? First of all, I collect like terms, right? So I will have 2x minus 4x is equal to what? Minus 1 minus 2. Is that okay? So I will have minus 2x is equal to what? Minus 3. Is that okay? So I will have minus 2x over minus 2 is equal to minus 3 over what? Minus 2. Is that right? I will divide both sides by minus 2, right? Because I want to get rid of this minus 2. So what do I have now? I will have x is equal to minus we cancel, that's plus 1 number 1 over 2. Is that okay? So we are solving linear equations. Is that okay? So what if I have another one? Let's say I have 2 into x plus 1 minus 3 into x plus 2 is equal to 5. Okay, so what do I do? First thing first, you open the bracket, right? Aha, that's what you do first. You open the bracket. So you have 2x, okay, 2x plus 2, okay, minus 3x, okay, minus 6 is equal to 5. Is that correct? So you collect like terms. So that's 2x minus 3x is equal to 5 minus 2 plus 6. Are you following? So what is 2x minus 3? That's minus x. Okay. Minus x is equal to what? Sorry. Minus x is equal to 5 minus 2. That's 3. 3 plus 3, that's 9. Is that okay? So what is now x? X is what? Minus 9. I'm looking for x. I'm not looking for minus x. I'm looking for what? For x, not minus x. So x is minus 9. Is that okay now?